Hi. So before we move on with our subject, there is one more thing we need to review, and this is derivatives and derivatives of exponential and logarithmic function. Okay, so let's just review all the formulas. Okay, derivative with respect to t out of e to the power of t is simply e to the power of t. And derivative of ln t is 1 over t. Not much problem here. Then let's start complicating everything here a little bit. So first, let's introduce a function in the exponent here. So derivative of e to the power f of t. Yes, how do we do? We take the function that is over here, we get that this is, and we differentiate it. So we get derivative, and we multiply it by exactly the same expression. Okay, let's just do a quick example on it. If we have y equals e to the power 4t squared minus t plus 1. In this case, derivative dy dt is, first we take this expression with this exponent and we calculate its derivative. We've got that this is 8t minus 1. And then we just multiply everything by the same expression we had at the beginning. Okay, now let's complicate a little bit formula for logarithms. So now if we have derivative of ln f of t, as a result we get f prime of t over f of t. And look, this expression will be very, very important to us because, as you will learn, this expression actually measures instantaneous growth rate. And as in this class we want to capture dynamics, this expression will show up very, very often. Okay, so now let's do one example on this function. So if we have y equal to ln 3t squared minus 2t, what are we going to do? Look, as the formula shows us, we should take what's in the logarithm and differentiate it. So dy dt, in this case this, we take the derivative of this function, which is 6t minus 2, and then we simply divide this by the original function, 3t squared minus 2t. And that's it. Now, if we have an exponential function with base different than e, derivative is ln b times b to the power of t. So look, the only thing we need to add here is the ln b expression. So again, let's use an example. If y is equal to 70, this means that dy dt is ln 7 times 7 to the power of t. Okay, and finally, we can complicate this expression even more. So what if we've got y, now we will be differentiating b to the power f of t. And look, knowing this formula and this formula, we can actually figure it out. First, we will need to have ln b, then we differentiate the function in the exponent, and then we multiply it by original function. Okay, so again, let's make an example. If we have y equals to 3 to the power t squared minus 7. Okay, so if I want to calculate dy dt right now, what do I do first? First, ln 3. Then I differentiate this expression. I get that this is 2t. And then I multiply it by the original function. Yeah. Okay. So now that we dealt with exponential functions, what about logarithms with base other than e? So if I have y, so if I want to differentiate a function logarithm with base b out of t, I'm getting 1 over ln b times t. Okay, let's use an example on it. Okay, let's just say that if y is equal to logarithm with base 1 over 2 t, then we've got the dy dt is first 1 over ln 1 over 2 multiplied by t. Okay, so the only formula left that we've got is formula for the case when we want to differentiate logarithm when we were using logarithm with base b out of f of t. And look, again, all we need to do is to combine this formula with the formula that we have here for a growth rate. So look, at the top we're going to have f prime of t divided by ln b multiplied by f of t. Okay, let's make an example. So if we've got that y is logarithm with base 2 out of 3t cubed minus plus 2t squared minus 1, then dy dt, so the derivative we're looking for is, we start with fraction r, and in the numerator, so at the top, we need to have the derivative of this expression. So this is 9t squared plus 4t. Then, in the bottom, we need to have natural logarithm of the base, which is ln 2, and times the original function. Okay, so look, I hope this allowed you to remember all the rules that we've learned during mathematics last year. But of course, it's good if we're going to learn something new. And look, today I would like to show you how to calculate derivatives easier using logarithms. And for this we will have a procedure that is very straightforward and requires just a couple of steps. Okay, let me show you an example. Let's just say the function we got is y t squared t plus 3 2t plus 1. Okay, so now our task is to find the derivative of this function, but you see that here this would be rather problematic because we have product and quotient, but as it turns out you can very easily differentiate function like this using logarithms. Okay, so look, how do we approach it? First, we take take natural logarithm of both sides. And look, if I'm going to take natural logarithm of both sides, I can use the properties of logarithms to make it into simpler expression. First, here we will have ln y, right? Now, a logarithm of a quotient is a difference of logarithms. So out of this, we would be able to get ln t squared minus ln t plus 3 2t plus 1. Okay, of course, in the future we can do it faster, but I just want to review all the steps. Now, what do we do next? Well, we can take this 2 out of the logarithm and we can divide this into 2 separate expressions. And look, because this is logarithm of a product, which is equal to the sum of the logarithms, but we have minus up front, we end up with minus ln t plus 3 minus ln 2t plus 1. Okay, and look, this is the first step. We logarithmize, we make it simpler. In the next step, we differentiate with respect to time, of course. But look, y is a function of time. So look, we're going to use here this rule. d dt ln f of t, which is equal to f prime of t over f of t. Right? But here we can write it a little bit differently. First, we need to have derivative of y with respect to t. So simply dy dt. Right? Now, the second thing is we need to have 1 over f of t, or in other words, 1 over y. Okay, now we differentiate what we've got here. Out of this we get 2 over t. Out of this we get minus 1 over t plus 3 minus 2 over 2t plus 1. Okay, and look, what we wanted to calculate is derivative of this expression with respect to t. And this derivative we've got over here. So look, the only thing left we've got to do right now is to multiply both sides of this equation by y. So we get the dy dt is equal, we open parenthesis, 2 over t minus 1 over t plus 3 minus 2 over 2t plus 1 times y. And look, actually we have everything calculated, but to make it, because this is of course the derivative we were looking for, but to make it look nicer, of course, in the last step we need to substitute for t. Unfortunately, I erased y. I'm sorry, substitute for y. And look, so we get in the end the dy dt is equal to 2 over t minus 1 over t plus 3 minus 2 over 2t plus 1 multiplied. And now we substitute for y, and y was equal to t squared over t plus 3 over times 2t plus 1. And of course we could multiply it all out to get the final result, but actually we can leave it in this way. So please remember that when we need to, when we have some complicated function and we need to differentiate it, very often a good approach to it is to first logarithmize the function, then differentiate. And look, I always tell in this class that if you do not know what to do in the next step of some exercise, probably good idea, first logarithmize, then differentiate, and something something should come out of this. Okay, so let's do one more example to make sure that we understand the procedure very well. Okay, so now let's just say that our task is to find the derivative of this function. Y equals t to the power of a times e to the power k t minus c. Look, again, this could be very problematic. We need to use product rule, but once we use logarithms, it will turn out that this is an extremely easy task. So what we do first, again, we start by logarithmizing. So we get ln y equals to, I can separate those two expressions. Okay, so we get ln t a to the power of a plus ln e to the power k t minus c. Okay, in the next step, of course, if you want, you can do it faster, but I just want to explain every step. We can take powers that we've got here, we can put them out of logarithms. We got a ln t plus k t minus c times ln e. Now, how much is ln e? Of course, ln e is equal to 1. So we can get rid out of this. And look, now we've got extremely easy function to differentiate. So we do it. Okay, let me do it for you. So I take derivative of both sides of this equation. So on the left hand side, as usual, we will get 1 over y times dy dt. And we remember this is the derivative we are looking for. Remember not to, because very often students forgot to take the last step. This is of course of key importance. Then, the derivative of this expression is simply a over t, and the derivative of this expression is just k. So we've got plus k. Now, all we have to do is to multiply both sides by y. So then we get that this is dy dt equals to a over t plus k times y. Or if we substitute for y, we get this is a over t plus k multiplied by the original expression t a e k t minus c. Okay, and basically this is it. This is how we use logarithms to make our job with differentiations easier. Okay, thank you for your attention and see you in the next video.